This episode is supported by CuriosityStream. If a light is on and no one's around to see it, is anything actually lit up? Well, the ancient Greeks didn't think so. They thought vision was due to rays shot out and returned to the eye. That's not how it works, unless your name's Cyclops. It took over 2,000 years from those Greeks all the way to Einstein to figure out how we see the world. And each answer led to other questions. Is light a wave or a particle? Is it instantaneous, or does it travel at some speed? Or does it even exist independent of our perception? Through these brilliant discoveries about light, we've gradually illuminated our place in the universe. Beyond what we can touch, smell, hear, and taste, we experience the universe through light. The first theories of vision came from the Greeks, who thought our eyes worked more like flashlights than cameras. And it made sense, kind of. At night, animals seem to have fire in their eyes, so why not humans too? Early mathematicians like Euclid worked out that light mostly traveled in straight lines and deciphered the geometry of how it's bent and reflected. We still use a lot of that today, but the nature of sight changed in the 10th century. An Arab Muslim named Ibn al-Haytham had a revolutionary idea. Instead of just accepting the Greeks' explanations, he actually tested them. He set up specific situations, varied different conditions. He did experiments, making him perhaps the first true scientist. Al-Haytham set up 2 lanterns outside a dark room. There was a hole in the wall. Inside the room, he saw 2 spots of light. If you cover a lantern, its spot disappeared. This reversed Euclid's idea. Our eyes don't give off light, they're just receivers. It proved light existed outside our bodies. Yeah, I know, it's obvious, but this was a huge step. But there was still a bunch we didn't understand. For most of our life experiences, light moves so fast, it might as well be instantaneous. And for a long time, that's what everyone thought. Dutch astronomer Ole Romer noticed eclipses of the moon. Io came later than expected when Earth and Jupiter's orbits were moving away, and sooner than expected when the planets moved closer. And this difference was explained by the time lag for light to make up the distance. Light travels at a speed. Once it was understood that light was a thing that traveled from one place to another, people like Newton began to take it apart. Prisms separate light and recombine it because different colors are all bent by different amounts, proving color is an intrinsic property of light, not just a trick of our perception. Newton noticed shining colored light on objects can make them appear any hue, but if you use their true color, they shine most brightly. This showed Newton pigments in objects worked subtractively. White light contains every color, and objects would absorb the colors they weren't and reflect the colors we see. Newton's contemporaries found that the bending of light in prisms, refraction, could be explained if light was actually a wave, and if that wave had different speeds in different media. And the famous double slit experiment found interference of light in a wave-like fashion, like ripples in a pond. Despite all this evidence that light acted like a wave, Newton and many others held on to the corpuscular theory, that light is composed of many, many tiny balls, all their own color. Newton was also really into alchemy, which had a thing for the number 7, so he divided the rainbow into 7 bands. Newton also thought color should be cyclical, so he mapped it to the musical scales. Of course, today we know light comes in a spectrum, not a circle. But to get to that, we have to go forward another 100 years to the astronomer William Herschel. Like Newton, Herschel used a prism to break up sunlight into its colors and measure temperatures across the rainbow. But when he put a thermometer in the dark, just past the red, it registered the highest temperature of all. There must be invisible light beyond what we can see. He called these heat rays, but today we know them as infrared. Johann Ritter decided to test the other end of the spectrum, past the purple. There he found chemical reactions happened fastest. He called these oxidizing rays, but today we call that higher energy light ultraviolet. In the 19th century, James Clerk Maxwell finally unified electricity and magnetism. He calculated that the speed of electromagnetic waves was the same as the speed of light. The particle theory was dead. Electromagnetic waves are light. Heat rays and chemical rays and visible light were all part of the same beast, the electromagnetic spectrum. A continuous gradient of waves all made of the same stuff extending out beyond each end of the tiny sliver we can see. The finishing touches came 100 years ago. Max Planck developed a theory of how energy is spread across the spectrum in little bits he called quanta. But to make this work, light had to be a particle, like Newton thought, each with a specific energy. Einstein realized this could explain the photoelectric effect. If light behaved like packets of waves, what we now call photons, it could explain why shining light beams on metals could release electrons. Single photons can knock single electrons out of their atom. By combining these features, they resolved the debate. Light is neither a wave nor a particle, but both, simultaneously. And this wave packet idea set the stage for modern quantum theory. But that's a story for another day. From humble beginnings in Greece and the Arab world, over 2,000 years, we've learned a lot about how we see the world and made the universe bigger and smaller in a lot of ways. Stay curious. Hey guys, if you're like me, you can probably never get enough of videos and documentaries full of facts and educational stuff about basically everything. If that sounds like you might like this. This week's episode is brought to you by CuriosityStream. It's a streaming service full of documentaries and nonfiction titles from great filmmakers, including exclusive originals. I really liked one called Light on Earth, a film about all the incredible ways that biological creatures create their own living light. It's beautiful and it's hosted by Sir David Attenborough, so what's not to love? Now, CuriosityStream gives you unlimited access starting at just $2.99 a month, but for you guys, you can get the first 2 months free if you sign up at curiositystream.com/smart. That promo code SMART will be good for 60 days just to check it out for free. They've got apps for lots of platforms, it's available in 196 countries, and it is a cool way to satisfy your curiosity. All right, see you next week.